Hello, friends. Welcome to Geometry Lesson 13, where we're going to be introducing some properties of triangles, ways of naming triangles. You're going to get to know triangles really well in this course, better than you had ever hoped to know triangles before. I guarantee it. Better than you thought you could know triangles. It's that surprising. But anyway, it's actually really beautiful because the things that we learn about triangles, then we can apply triangles all over the place. Um, and so let's begin. The first way that we can classify triangles, we can start to give them names, types of triangles, is by classifying them according to their angles. In a triangle, if all of the angles are acute, again, acute means less than 90 degrees. So if all of the angles are less than 90 degrees, that's an acute triangle. If one of the angles is bigger than 90 degrees, it's called an obtuse triangle. It's obtuse. There's only one angle that's bigger than 90 because you can't have more than one angle bigger than 90 degrees in a triangle. It wouldn't be a triangle. It would be open or something like that. And so even if there's just one angle bigger than 90 degrees, we call that an obtuse triangle. If there is one right angle, then we call that a right triangle. And we're going to get to know right triangles really well also. And then there's a special kind of angle where all of the angles are um, equivalent. They're all equal angle measurement. They're all congruent angles, and this is an equiangular triangle. Sometimes we call this a regular triangle as well. Um, and so the key thing there is, since it's equiangular, that means that all three angles, the measure of the angles, are all 60 degrees. All these angles are congruent to each other, right? Okay, so those are the four different types of, actually three different types of um, triangles that we can have based on their angle measurements. And then the equiangular triangle is also an acute triangle. Since it's, all the angles are the same, they're all 60 degrees, they're all acute, and so it's an acute triangle as well. We can also name triangles according to their sides. If all the sides are congruent to each other, then we have an equilateral triangle. Lateral meaning side, equal side triangle. By the way, the equilateral and the equiangular triangle are the same, right? If it's equiangular, it's equilateral. If it's equilateral, it's equiangular. We call this a regular triangle. You'll see that in some contexts. Regular meaning equiangular, equilateral. That applies to triangles, and then it applies to other figures as well. If two of the sides are congruent, then it's an isosceles triangle. Iso meaning the same, and then scales means legs. So it has two legs that are the same. Okay, isosceles and equilateral are not the same. Like an equilateral is not an isosceles just plus the third side. Isosceles specifically refers to a triangle where there are two congruent sides and the third side is not congruent. If none of the sides are congruent, it's called a scalene triangle. Okay, and so we can classify angles according to sides, classify triangles according to their angles as well. Uh, and then we also want to be able to name parts of triangles. A vertex. Vertex is basically just a corner of the triangle. Um, Oftentimes it'll refer to a particular vertex based on context. We'll be able to see, oh, we're talking about this particular. So for example, in the context of what we're talking about here, I'm going to be talking about the height, I've labeled these corners as the vertices. Vertices is just the plural of vertex. It's like index and indices, that kind of thing. So anyway, the base just refers to the bottom. The base can be any side of the triangle. It doesn't have to be, because then if you take a triangle and you turn it, now you've got a different base. Okay, and so the way that I've labeled it here, just the way that I've drawn these triangles, the base is this bottom side, and then the height is the distance perpendicular to the base to the opposite vertex. Okay, and so these yellow dotted lines here represent the heights of these three triangles. In an acute triangle, it's easy to do, right? Because you can connect to the other side. The right triangle, the height is going to be one of the sides if the base is, one of the shorter sides, not opposite the right angle. As long as your vertex is not the right angle, then your height is going to be one of the sides. If you've got an obtuse triangle, how do you draw the height? Well, what you do is you extend the base like this, and then you draw the vertex, draw from the vertex down to that extension of the base. Okay. Now that we have those things named, we can come up with the formula for the area of a triangle. Formula for the area of the triangle is 1/2 of the base times the height. Notice we need that vocabulary first. What is the base? What is the height? Well, now that we know that, we can apply this. And so here's an example. So if the height is 5 and the base is 6, so 1/2 the base, 6, and we've got units here, times height, 5. And then you can do whatever arithmetic you want here. Personally, I would do 1/2 times 6. So I get 3, 3 times 5. So the answer here is 15. The units are square meters. Just think of the unit as like a variable in algebra. You take m times m and multiply them together. What do you get? M squared. So 15 m squared. That means that there are 15 square meters. When it comes to measurements like this and units, it's good to pay attention to those, keep track of them, and put them in your answer. It's important. As a physics teacher, I see that a lot, and I emphasize that because it makes a difference, right? If I tell you that my child is 5, it makes a difference if I'm saying 5 days, 5 weeks, 5 months, 5 years. The units make a difference. So let's take a look at this next example. So if it has a height of 4 inches and a base of 8 inches, again, I would just do 1/2 base times height, so that's 8 inches times 4 inches. Again, I would do 1/2 of 8, I'll get 4. 4 times 4 is 16, so 16 inches squared. And I treat IN as one thing. I'm not going to write I squared, N squared. It's just inches. That's the unit that I'm squaring. So that's the area of that triangle. And then this last triangle, again, 1/2 base times height. So 1/2 of 12 centimeters times 10 centimeters. 1/2 of the base times the height. So half of 12 is 6. 6 times 10 is 60 centimeters squared. So introduction to triangles, how we name triangles, parts of triangles, and then the area of a triangle. Thanks for watching. Don't forget to like and subscribe.